Welcome to session 2 today on the environmental impacts of infrastructure. My name is Samantha Ahern. I work with the Advanced Research Computing Centre at University College London. My role is predominantly around teaching and learning. In effect, I'm the education practice lead. I was a computer scientist, and before that, I was an electrical and electronic engineer. So some of this feels very much into my wheelhouse. And I've actually been doing a lot of work around some of this in my role as an educator and things that come up in my previous life as an engineer. Please use the Slido. The QR codes are on your table and on the screen. So, the environmental impacts of infrastructure. And this is quite an interesting one. And this has been an issue for a long time, and not just an AI boom issue. So, we've known for a long time there's been issues around power and data centres, and that is kind of increasing. We know around cooling has been problematic for a number of years. The fact that a few years ago, Thames Water had an investigation about the water being taken out of the drinking water system in Greater London to cool data centres, and there was kind of a ban or a freeze on the building of new data centres. And there's been a big question marks about where and how we put data centres and increased drought risk due to changes in climate. Alongside that, and some of the stuff that I was involved in a long time ago was around the manufacture of the hardware. And this is kind of where we see an awful lot of issues. So probably about 10 years ago, I was involved in a hackathon for the Dutch government looking at the movement of illegal gold. So gold is extracted illegally in much the same way that diamonds are. And people know an awful lot about blood diamonds, but maybe not so much about blood gold and the other minerals that are in our supply chain. And this is extracted in dangerous situations, in unhealthy situations, and fund things that we'd rather they didn't fund. And it's not just gold. We know there's massive risks to the salt flats due to extraction of lithium and so on. But alongside that harm of that extraction is what happens to those materials afterwards. So we know that the recycling is not good. We know that a lot of this is toxic and ends up getting dumped and causing massive harm. So I think part of this on the infrastructure, certainly on the tin side, is what do we do with our tin? My question is, how do we extend the life of that tin to make that worth it? And then what do we do? So my first question is, and I'm not necessarily in the order of that, and I've lost the question.
Should we do intros while you're finding this?
Yeah, I know. So the question is actually, what are the specific environmental impacts of DRI, and how can we measure and reduce that carbon footprint?
Okay. Shall I start with an intro?
Yeah, oh, sorry. Sorry. Should I let people introduce themselves? Because I got a bit... So we have from right to left. So we have Eccleston from Bristol. And you're all sat in completely the wrong order. Michael Ayres from the University of Manchester. Fernando, Andreu from the University of Durham. We had Fred Sonnenwald from Sheffield. And Michael Rudgyard?
Rudgyard, yes.
Yeah, from Alces Flight. So if your panel would like to introduce yourself, starting with Polly, and then we will dig into the questions. As you can tell, I'm a little bit too excited by the topic.
Hard to not get excited about this topic. So. I'm Polly Eccleston. I'm from the University of Bristol. For the last 10 years, I've been working in the research IT for research focus space, and with the Advanced Computing Research Group, providing HPC, research data storage and research software engineering skills to academics at the University of Bristol. I did my Masters in Computer Science in the last century, also at Bristol, and then worked for 10 years in software companies before I came back into the academia fold. I will pass on to
Thanks,
Bill.
So, yeah, hi again, everyone. I'm Bill, Strategic Lead for Research Data Management at the University of Manchester. So I'm based in the library. My team that manage kind of the RDM service are part of the library's Office for Open Research. I've been in the library world for 8 years now. I was in IT services, infrastructure management for a long time before that. So my old team used to manage lots of things to do with computes and networks and storage. In the old days when that was done locally within faculties rather than it all being, generally an institutional level and obviously as we see across the N8. So I'm here to give a library perspective and hopefully think about how things join up across the whole life cycle.
Hello, my name is Fernando, and I work for Durham University. As you can see, I am in the team that manages BEAD. You're probably familiar with it. So I initially studied informatics and worked in standard vanilla IT. Then it caught my attention that every year we needed to increase the amperage in the data center. So after a few years, I decided to study masters in renewable energy. And in there I learned not just about electricity and energy and consumption, but other important things such as life cycle analysis. Then I went into biomass energy production for a bit, but now I am back in the computing industry. I work for Durham University now in the Advanced Research Computing Directorate. Yeah, thanks.
Hi, I'm Fred Sonnenwald. I'm a research data engineer at the University of Sheffield. I've only been that for about a year. Before that, I spent a very long time as a civil engineer looking, among other things, at sustainable drainage. So I've had a little bit of an eye on the sustainability problem from a different point of view, from water and water quality and things like that. But now, having moved from civil to, sort of peeking behind the curtain, I'm starting to get a better picture for sort of the environmental impact of sort of compute. I think that's really interesting, but I didn't really see that at all as a user of the computing systems. So I'm quite interested in how we can communicate these things to users now.
Okay, I'm Michael Rudgyard, part-time CEO at Alces Flight. My background was as an academic. I used to be a mathematician and a CFD guy. Left academia in about 2000, set up a few startup companies, one of which delivered cluster computers to several, including people in the audience here, in the early 2000s. I also founded a company called Alinea, so I hope some of you use the parallel debugger DDT, which is my baby. I joined Alces a couple of years ago. I've been helping them with their strategy, and as part of that, one of the things we've been taking very seriously is sustainability. So I've been doing research on sustainability, which I've talked about at several universities and several other events around the UK.
Cool. So I will be upfront and honest to say that one of the things I put in our student-facing course in Gen AI was about environmental impact of water and power, front and centre. I put the ethics up front, and that was one of the first things I said about harms to people and harms to the environment. So let's go then back to our first question, which is, what are the specific impacts of our DRI, and how can we measure and reduce them? So maybe, Michael, I will start with you.
Well, I focus on that question. I'd focus on measurement, because a lot of people don't understand the CO2 they're emitting in their HPC systems. But, obviously, most of that comes from running the computer itself. So you need to be able to monitor the power use of your computer. But also you need to monitor the power use of your data center that's housing your computer, and possibly other ancillary energy use as part of that. We do that Alces Flight for some of our customers. We actually provide them with quite detailed data in a quarterly report on their energy usage and so on. And I know some universities do that, but I would probably say that not enough people in both the academic and the commercial sector actually have a good understanding of the energy they use. And I think it's important because it could guide some very important decisions, not least how much money you could potentially save or how much money you're actually spending. I think for a long time, HPC in the UK, the use of HPC has been separated. The people that use HPC have not paid the power bills. And I think what we're seeing at the moment is lots of universities actually waking up, possibly due to the Ukraine crisis, how much their electricity is costing them. It's causing major problems at certain universities, I know that for sure. But monitoring and understanding use is the first part of that story, I'd say.
At which point, I want to go on to Fernando about this energy part, because I know certainly in the UK that there was a concern last week around our gas stores, and that still plays a part in power generation. So how do you see the power dynamic of this playing out?
I think that power is only one side of it. If we talk about the specific environmental impacts, we have to look at everything. From the chemicals used to create the equipment, the water, the tantalum, the tin, the tungsten, the gold, the cobalt, that the hardware needs, to the impact on humans. You know, there are human rights violations, child labor, conflict materials, and when we get to the energy, which is the specific question, sorry, is that on the one side, people focus on CO2 emissions, but people don't really understand how much of it, as our colleague here said, it is. But getting hold of this energy also creates a lot of conflicts, invasions of countries with oil, invasions of countries with gas. We need to get that from somewhere. Even probably some of the rare earths from the wind turbines that we have and that we hope that will help us come from conflict areas. Yes, people are waking up after the war in the Ukraine, probably. But I think that there is not enough emphasis on measuring. People don't, at the moment with, well, my feeling is, and you know, correct me if I am wrong, but many people talk about CO2 emissions and net zero and so forth, but they omit other environmental damage, damage to ecological services, and they are in, some people are in a bit of the position we were maybe 20 years, 30 years ago, when people thought that by recycling the paper we would contribute towards solving a problem, but we don't really know what is the size of the problem, and there is no measuring at every single stage of the whole life cycle of our equipment and our facilities, including the energy.
So Fred, do you want to follow up on that? So you say you've done that move from civic and that change in water measurement. Yeah,
it's you know, one of the things as a civil engineer is you really start to look at these life cycle problems, and you know the classic example is the building of the building and the materials that go in and the horrific environmental impacts of concrete, which is by and large a single-use material, which is fantastic, which is why we try and design buildings for 50-year lifetimes. And the sad part of HPC is we can't do a 50-year lifetime with HPC. We can barely manage a 5-year lifetime. And we need to figure out ways of getting more out of the computers to, you know, if not minimize the damage, but amortize the damage, you know, pay it back over a longer period. You know, and the other half of that is then user education. You know, once we have these measurements, how do we make these measurements make sense to someone that's not an energy person, someone that's not really a compute person? You're going to start having a lot more people using these big compute resources that aren't technical people. You know, how much energy does an LLM query? You know, when someone's using ChatGPT or Gemini, how much power is that using? And that's just, you know, the first step, and then getting onto the resources that built that, the energy cost of training that, and you know, communicating and making aware and finding a way to get people to engage and get away from the researcher mentality of as long as it works, which is, you know, how we end up with jobs that are 10% efficient on CPU time, which is a horrific waste of resources.
Yeah, so on some of that, so in the last century, I built surround sound equipment, and you couldn't buy DVD drives. Toshiba just would not sell them to you. So we had to buy the actual full machine from Toshiba, strip it down to take the drive out to put into another device. And the waste of that was horrific, but that was the only way we could do it, because they wouldn't sell us the drive on its own. And we were literally stripping down one thing to put it into an equivalent product with better playback and things. And that's kind of, to a certain extent, some of the wastage that we're seeing now. So do we think there's enough strategic importance put on this and this life cycle of these devices?
Yeah, no, and I think that is where the new measurement effort needs to go. I agree that we're not even there on the usage and the monitoring of equipment and the power use during its lifetime when we have it in situ in the UK or in even more environmentally friendly data centre and power usage locations. But talking to Professor Chris Priest, who is a Professor of Sustainable Computing Systems at the University of Bristol, he said really that the new focus that he's trying to drive is on the measurement of the Scope 3 and the embodied carbon in terms of generating that equipment. And it is in its infancy. and there aren't standards in place, and there's not really currently a regulatory framework around that point. But they are working and doing projects with University of Bristol and in Edinburgh University, just really trying to look at the detail of the entire supply chain, take that information, and then I think our role as DRI professionals can be to inform and educate our young people as they're coming through, and being trained on sustainable computing within our faculties, and also put that pressure on the supply chain for better and improved quality of reporting in this area. Another thing that we can do is sort of inform policy. So there was a PhD student working in that group who did an analysis of the University of Bristol use in terms of scope 3 and embodied carbon and the supply chain piece. And she's now a member of Parliament and part of the select committee for net zero, and is actually going to focus on sort of improving some of those regulatory frameworks as well. So I think as thought leaders in this field, we can have an influence over and above our size as purchasers. So there's some work to be done.
That whole embodied carbon's an interesting thing, because that's what drives me mad about electric cars. Bill, do you have any?
Yeah, thanks. So, I mean, the library is not itself too bad in terms of the environmental impact. We have lots of dry books on shelves that don't use or generate electricity. But to be less flippant, within the area of the library that I work in and that most institutional libraries will have, we do see, obviously, through things like the data management plans, the DMPs, people are telling us what they're going to use and how they're going to use it and how much data they will generate and the kind of facilities they'll use. And to return to, I think, one of the points that Fernando made is that how do we measure this? Well, this is an ambition for us rather than something we're actually doing in a concrete way at the moment. But certainly, if we can leverage the kind of information that's been given to us at that stage, and another thing that libraries are very good at is investigating these kind of things and reporting on them and producing information about how to collect that information, then actually we would be in a better position to look at the life cycle from end to end, from generation through analysis, through data publishing, through preservation, and maybe contribute to efforts that will give us that much better visibility of the impact across the life cycle. And that's kind of where I see the library having hopefully a really valid role in that as we move into the next phase of doing this kind of work.
So with that, so are there any particular initiatives that you feel are significantly contributing to that at the moment?
For me?
Or in general today?
So contribute, I'm not aware on that space. I think we probably need more activity within that area. I think there are things in terms of optimization of power use that can be really impactful, particularly in high performance computing. So the increased focus on research software engineering and making the best use of facilities actually helps you get the most value and the most scientific value out of that equipment once it has been created and set up. And I think that's also an area of focus, because really, rather than reducing the power use, you want to kind of maximise the amount of valuable science that comes out of that equipment that's been produced at such a high cost.
I mean, that goes back to the monitoring point. When I said monitoring, it's not just about how much energy you're using, it's how much of that energy you're using well. So if you've got a system that continuously fails, then that's not good, because you're losing lots of potential computations. If you've got users who are running applications over large numbers of nodes, when their application doesn't scale to that number of nodes, that's not a good thing. So there's a lot of the monitoring goes down to monitoring the usage of the system and not just the electricity used by the system. In terms of other things that we can learn from, I noted down a few. There's something called the Energy Efficient Working Group for HPC. That's a US-led initiative, but it's an international initiative, so I think there's some European input there. I can give you details after the talk if you're interested. There's something called the Net Drive project, which I've given talks at, which is a network for sustainable digital research infrastructure, vision and expertise. So that's funded by the UK government through... who pays for your machines? I can't remember what they're called. Those are they've not been. We've run two now sustainable reality events through Alces. So those are things that we've done as a company. We've had some very good speakers there, and it's been very interesting. So there are things out there, but I don't think there's enough focus on this as yet. There's not enough good information out there, actually.
So do we think that that's hindering kind of policy and strategic moves, the lack of hard data, as it were?
Either the lack of hard data or the lack of the awareness of the data that does exist.
Like,
we do know how much power the entire HPC is using. That's the data center builds us on it. So, someone's got the numbers, but the numbers don't make it very far after they get to us. We need to, at least particularly at Sheffield, it's one of the things we're looking at is better conveying this information. And, I haven't worked at every HE of the HPC in the UK, but I imagine a good chunk of them are in a similar position where this information isn't quite making it through to users yet. And there will be people who will see this and will shout about it, and that will help drive policy at the universities, and lead towards bigger requirements for changes in sustainability strategies and sustainability goals for the HEs and for the sector. It's hard to get people engaged if no one knows there's a problem.
So that ties into the question around what are our institutions doing about this? So, are we actively doing things to reduce the environmental impact of DRI?
So what some institutions are doing, and what we're trying to do is, for example, there are certain things in policy we cannot control, but there are certain things that we can do locally. For example, moving to liquid cooling of the data centers, that reduces the amount of electricity spectacularly. In Durham, we got funding to explore the possibility of reuse the heat from the data center. So some people can reuse it by plumbing it directly into district heating. We're going to try to see whether we can store it in the mines underneath the university. But also, the reality is that the amount of electricity and resources is such that if we want to get to net zero, if that's what we want, those emissions need to be offset. And we need to go into the non-glamorous areas of increasing the efficiency, to not having this 10% efficient job, as you mentioned. And we need to reduce the usage. So just get people to make use of the machines if they need to, but if they don't, then maybe they shouldn't. But for the non-glamorous work, we need to have good measurements of how much we're spending.
I mean, if I can chip in from a local perspective in Manchester, so just to reflect on that question, one of the things that we're doing through a project in our research lifecycle programme, which is collaboration between research IT and IT services in the library, is we're looking at I think a challenge that we're a common one across the room here, the issue of cold data, which is our big isolon array across the two data centres is multiple petabytes, and lots of that data doesn't need to be on expensive, hot, energy-intensive spinning disks. And we have a project underway now which is really looking at moving as much of that as we can onto a much longer-term storage option, probably some kind of commercial tape solution, which will be vastly reducing the energy usage and indeed the cost of that side of it. So that's a local thing that we're doing. I'm interested to know, I don't really know if this is something that the N8 is grasping across the institutions in a joined up way, about that issue of the data that is there, which is being retained because the funders say we have to, but it isn't going to be published, it won't be analysed again. We need to keep it, but not on expensive spinning disks. So it's an interesting question, I guess.
So I guess we can throw that out. So is there anyone that is working in that data storage that has kind of considered this?
There's a mic.
Yeah, if you go to the back first. Yes, please.
So Saul Cousins from University of Sheffield. This is one of our active projects as well. I'm afraid I don't have a solution for you, so I don't know how we're going to do it either, but exactly the same problem. Yeah. In terms of sharing, whether it's something that the N8 looks at, or whether this is exactly the kind of thing that JISC should be doing for all universities, as a shared service, having a long-term storage solution which is environmentally friendly, as well as cost effective. Obviously, some of those commercial offerings, we start looking at cloud as well and seeing how cheaply we can do that. Then we've got transfer costs, which are always the bait and switch that they provide for us. So you can put it there, but you can't have it back unless you've got a big pile of money.
Polly, did you want
Yeah, I was just going to say, in Bristol, we've obviously had the good fortune and challenge of spinning up the Isambard AI and Isambard 3 services, but that has given Simon McIntosh-Smith from the University of Bristol the opportunity to really focus on how you would produce a new large-scale AI system in the most efficient way possible as of last year. And he's told me that how he managed to get that number 2 in the Green 500 last year in 2024 was that obviously he chose the most energy efficient type of processor available at the time, which was the Grace Hopper GPU. They've used direct liquid cooling as part of the infrastructure with that better availability for heat reuse potential. That's still work in progress in terms of sort of talks with the district heat setup system in Bristol. They've also using the modular data centre process where they can kind of create modular data centre for the exact size and fit of that particular system. And the estimate for what that does in terms of the embodied carbon of the actual data centre is that that's an approximate 40% reduction over a standard bricks and mortar data centre. And then they've also looked at obviously the carbon or the energy use for powering that system, and it's using a mix of nuclear and wind in terms of its purchase agreed environment pace there. The other thing that they've done is to really try and optimise the software stack so that it's as energy efficient as possible, and then make the ease of use of the system. The other bit is about the control of what's run on there. So obviously with a resource of that scale, there will be a technical review panel to assess the validity of the approaches done and a team to help you optimise how you're doing things, as well as committees for assessing the value of the work that's being done on there, and all those things that obviously done at a large scale in that system. You can kind of apply those principles in a smaller way in your own local infrastructure as well.
Yeah, so there is a question here about how we balance the need for that high performance compute with the environment. I think you kind of partly answered that, and nuclear is an interesting one, given that some large companies have said they want to set up their own nuclear power stations to fuel their data centres. And, you know, there are rumblings in the States around doubling down on fossil fuel to fund data centres as well, and, you know, buying countries. So to the rest of the panel then, how do we balance that our need for compute, and that obviously there was the big announcement around AI on Monday. How does that play with this need to consider these impacts? Michael, you offer computer service. So.
I don't think anyone's, I mean, as a scientist at heart, I think HPC is important for science and important for us, you know, to use to move forward as a tool. So I'm not someone that would necessarily suggest we do less HPC, which is a simple answer out of this. I think one of the things that I'm surprised about is that as scientists, there isn't enough debate going on about all of this. So, you know, there's interesting discussions, but, you know, one of the things we've heard, for example, is embedded carbon. Now, in HPC, my understanding is, and I could be wrong, and I'd be happy for someone to disprove this to me, but because we use our computers, you know, 90% capacity or something like that, the embedded carbon is relatively small compared with the carbon from running the machine. That's not necessarily the case for general data centers where the machines aren't running at 100%, because of course these days chips use more electricity and they get hotter and things when they're being used all of the time. So the embedded carbon, whilst an important part, is a relatively small part of the overall picture when we talk about HPC. It's really got to be focused on you know, the use of energy, really. And there's some interesting things that aren't talked about. For example, you know, in the UK, we lost 10% of our energy just moving it from up and down the country. Okay? And there's certain areas of the UK that aren't particularly green, i.e. the energy mix in that part of the UK is not as green as other parts of the UK. So there's issues like in town centres, if we had to hit our carbon, if we're going to go through energy transition, so you think of energy transition, every car in a city is going to be an electric car, needs charging. Every house is going to use air source heat pumps, need electricity. So most of the major cities in the UK, if we were to hit our goals, then by 2030, they're going to have between 20 and 25% more electrical energy in city centres. Now, I would say realistically, most of the people use the HPC and not everyone. I mean, there are HPC that need to be near where the experiments are done. Most of us, it doesn't really matter where the computation's done. So having these proper grown-up conversations about where things should be done is not really happening as much as it should. And I guess that's part of the debate that I would like to think as scientists we should be having openly. And, you know, I'd love someone to... I've done quite a lot of research into what I see as the facts, but that's just me doing research. And I don't think there's enough research going on, enough attention paid by the universities to what decisions they should be making. And I think from what I've seen, there's some very clear decisions come out of this.
So is some of what we're seeing greenwashing or true sustainability? So some of what I see around electric cars is greenwashing, because actually the production of electric cars is difficult, reusing the battery is difficult, the electricity generation is difficult, yet it's seen as this solution which probably isn't as sustainable as it could be. Are we seeing kind of some of the same recurrent initiatives in our HPC space, or do you think things are more genuinely sustainable?
We don't necessarily quite know yet, but I think, you know, following up on the, you know, these sorts of discussions that we're maybe not having is, do we need a tier 3 HPC? Should we be building more centralized tier 2 HPCs, getting economies of scale, having to do one district heating hookup? You know, can we heat one entire city with an HPC and just have one big HPC across the UK, and, you know, everyone gets a little slice? You know, there are more out-of-the-box type solutions, but we're kind of stuck to some extent on, you know, we have a cycle we're sort of sitting to, and something like that is a really big initiative and requires lots of buy-in, and it's difficult to do that. How do we know a tier 2 is going to happen? Can we get funding for that? Because that's now a big pot of money that has to come from somewhere. And I don't know, I sit quite low on the totem pole. I think there is more we could be discussing at a wider scale.
It's an interesting point. That's in Norway, all of the Norwegian universities, all of their HPCs are in a data centre in a fjord in northern Norway. So they're not, it's not a shared resource, but they've all placed their HPCs in a green data centre where energy production, the CO2 in the energy is very low. So that's an interesting model where everyone still has their HPC, but it's not on campus.
And thoughts, or there is a question at the top here, actually about what do you do or can you do with a life-expired HPC cluster, where the hardware is still very performant, but it's not nearly as efficient as newer hardware. I think that is a difficult question, but maybe a question that we should start thinking about. Any ideas on the panel?
So our University of Sheffield, we cycle through our HPCs. Our Shark HPC, we decommissioned just over a year ago, and it has made its way to Ukraine, where it's being used at Kyiv University, I think it is. And, you know, the hardware is still perfectly cromulent. It can still do work. You know, if we do acknowledge there's a lot of embedded costs and a lot of environmental harm that's already done, getting the most out of it means running it into the ground until it doesn't work anymore. And we might need to put it in the fjords where there is cheap, clean, green energy, and just keep using it, and maybe find the right workloads for the right sorts of hardware. Maybe there's a little bit more engineering that goes into figuring out what is the best sort of thing to run on this CPU that gets the most performance for watt for what we can do. And it's probably quite a big engineering challenge to benchmark lots of codes and come up with ways of doing this, but I'd quite like it if we ran computers longer.
But again, we have to be scientists about this, right? So if we're using this amount of energy, a watt, and we want so many gigaflops, then the parameter we're interested in gigaflop per watt.
Yeah.
Okay? Or gigaflop per kilogram of CO2. So there comes a point where using old hardware just doesn't make sense anymore, because for the same power, we can get many more flops if we're just thinking pure HPC terms. So, but I agree with you that we can extend the lifetime. One of the things that we looked at was we did a spreadsheet analysis of a new machine that we just sold to a customer and a machine that was coming out of that same customer that was 5 years old. And in terms of both CO2 and cost, the best solution we could come up with was moving it to Iceland. In Iceland, the cost of power is about 5p a kilowatt hour. So if you buy a brand new HPC system, and you look at the gigaflops per pound, most of your cost is now in your energy. That may have changed recently because the price of energy has dropped a little bit. But when I did the analysis, most of your 5-year cost was in the cost of electricity. Yeah. And in the UK, most of us are paying between 25 and 35p a kilowatt hour, I'd suggest. So if you're paying 5p a kilowatt hour, it completely changes the economics of running an old HPC system. So the simple answer to that particular question may be to just move this resource to where it's cheap to run, and then you can extend the lifetime and possibly CO2.
I mean, one of my big questions is, does everything have to be bigger and faster to do decent scientific compute?
I agree. I think gigaflop per watt is a little bit misleading. I think kind of what we're after is impact per watt, right? What's the most good we can do with the energy spent? And if that's a researcher someplace else with whatever computer they have, and not necessarily the latest and greatest, then that impact being made is the important output of the research. It's not that we've crunched numbers, it's that we've done something with the number crunching.
So I guess that leads into question 3 here. We kind of touched on question 2 already a little bit, about can we afford to wait for that good measurement, or are there things that we can do to start making improvements? So can we, so I know that we have Project Contender at my institution. We've looked at an analog machine and what we can run on that, because we know that it uses less energy and things. So different compute on different hardware we've been investigating. But are there kind of things that we can encourage now to address some of this before we get some of those hard numbers?
Education for users.
Yeah, start planning for the measurements, or, do small things, as I mentioned, as, moving into liquid cooling, for example. Something that I wanted to ask, though, is for the calculations that made for going back to reusing the hardware, sometimes you can reuse it, and sometimes, if you take into account the embedded energy and the environmental impact, and not just the carbon emissions of electricity, the figures might be very different. But on the other side, some of the high-performance computing equipment, it's very difficult to reuse it because some of the key parts, for example, the cabling, that is very expensive, all the fiber optic cables, the high-speed cables, they degrade because they are hammered so hard that the heat physically disintegrates them. So if you want to move that machine to a different place or to give it to someone, that person must be able to afford new cabling. And that sometimes is really, really expensive. Ideally, I would like to see if it is possible to increase the maintenance of equipment, because sometimes the equipment is not ditched because it's too slow and it doesn't give you enough cycles per unit or whatever it might be. But it's just that it's out of maintenance, and you need, and beyond certain number of years, it's very expensive. That's all.
So we have a warranty issue with some of our machines, and that's why they get replaced. They can be perfectly usable, but they're out of warranty, and then that causes us an issue. Polly?
Yeah, I was just going to say it would be great if we could tackle that problem of how to make the best use of that equipment once it reaches end of life as a community, because it is a relatively sort of specialist area, isn't it? And I think we do need more data. But in terms of answering the question, yeah, I think we do need to begin. So I think there is sometimes a temptation with scientists to go to the next level of precision on the problem, and actually I've been caught up with not showing an approximate sort of carbon figure to our users, because it's not precise enough, it's not accurate enough, it's not good enough, and actually just sort of making that visible to our community, even if we know it's a little bit imprecise, is a kind of good place to start. And in the same way, showing that to decision makers. So I'm involved in quite a lot of the meetings with the busy senior stakeholders, and I have to say that the power increase did take those decisions a little bit up the agenda, because you could show the financial cost alongside the greenhouse gas and carbon emission cost as well. But yeah, just showing that that's sort of a baseline figure, and not being as precise as we need in some of those areas to begin taking action and to begin taking decisions and having an impact. But then equally, because we are in a scientific area, really taking that opportunity to do the work and move the knowledge and understanding forward, and working as a community and learning from some of the good work already done to actually get really informed best practice and informed policy as well, and regulatory frameworks, so that we can improve going forward.
Because there's been an obsession with double precision in things for a long time, and now they've gone, actually, some of this ML stuff we can just do it with single precision. I'm like,
And yet,
in the first place.
you have some areas of society where there is absolutely no interest whatsoever in having any accounting. So, for example, I don't know, who can say what the increase in emissions can be by after increasing the military budget of NATO countries to 2 or 3%, yes? Who cares? The politicians said, let's do it, and that's it, yeah? So I don't really know what sort of impact can we make, or how important it is that we go to double figure precision when there are other parts of society they don't really care.
So are there any final closing comments from the panel?
I think just following on that last question, I mean, I think monitoring we can use to better use existing resources. But in terms of getting the information that I talked about right at the start, a lot of that's used to persuade the stakeholders to make a change. Okay? I think there's enough information out there for people to make rapid decisions and execute them, and make a significant change in their carbon impact. And that's what York University did by moving, in their case, their machine to northern Sweden, where they were using heat reuse at the data centre as well. I would suggest that anyone planning a new HPC in the UK that's not considering heat reuse really is there's no real excuse for it at this point in time. We've got to start thinking that way. So I think there are very simple decisions that people can make now. The information is just used to persuade the stakeholders that they need to make those decisions.
So, right, has anyone seen the second Aquaman film? That is truly awful, but there is kind of a moral of the timing that actually there was this energy source that the Atlanteans found, and then they found that it was brilliant, but it completely destroyed the planet, and then the rest of Atlantis rose up and embedded the bad guy in ice and things, and then it kind of got refounded. And are we almost at that point of rising up against some of the things that are being driven to us, and, to all intents and purposes, putting some things on ice to make real change? At which point it is now lunchtime, and I will leave you to that thought. It's not lunchtime, it's break. You've got half an hour left. I clearly have not drunk enough coffee this morning. Thank you, everyone.